Hello everybody, and welcome to Unit 12. Here we're going to be covering glaciers. So, previous units we've talked about surface water, we've talked about groundwater. Now we're finally going to get to the part of hydrologic cycle that is solid water and ice inside glaciers. So, what are we talking about when we say glaciers? Anybody says glaciers. Some sort of semi-permanently or permanently frozen body of ice. Largely this is going to be snow which has melted and recrystallized. Whenever it does this, it grows more and more compact than you might think of for regular snow. And these tend to move relatively slowly, mostly driven by gravity. Radius 10 inches a day. For reference, tectonic plates move at about centimeters per year. So compared to that, it's actually really quick, geologically speaking. So these cover about 10% of the Earth's surface, which is really a lot of area, even though 10% sounds small. Have about 200,000 glaciers worldwide, and if these all melted, you would get 230 feet rise in sea level. So this is a considerable amount of Earth's water, which is locked up inside of these. And quickly, we'll take a look. This is our cross-section of the glacier. Like we've sliced one open, and we're looking at it from the side here. Glacier is moving down, driven by gravity. And we talk about this accumulation zone up high, where the glacier is actually building and getting larger, and the ablation zone down lower, the glacier is actually melting and getting smaller. And of course, depending on the relative amounts of these, that determines our equilibrium line, and whether the glacier as a whole is actually getting bigger and moving out, or if it's getting smaller, actually receding up into the mountain range. So, where are the glaciers? So the blue this map here are the glaciers, and the white are actually ice sheets. So the ice sheets do not move, whereas glaciers typically do. That's the difference between these. And since ice sheets don't move, there's not always a whole lot to talk about there. Glaciers are going to be a lot more interesting. I can actually zoom in on a place we all know and love here, North America, looking at places in Greenland. Well, not a place we all know and love, but northern Canada, Alaska over here, considerable amount of glaciers here in the northern Rockies, as well as closest glaciers actually to those of us here in Phoenix, going to be in the Sierra Nevadas over in California. So what are our different types of glaciers? We're going to have 5, and it really depends on the location and the nearby topography for these. A lot of times, as you can see in this diagram, it's one sort of continuous block of ice, but depending on where we are in the block, we give it a different name, even though it's sort of technically this one solid body. So we're going to have cirque glaciers, valley glaciers, ice caps, fjord glaciers, and Piedmont glaciers. So first, what are we talking about for cirque glaciers? Personally, I just remember this is a little bit like circle, and then I imagine these sort of bowl shapes for the glaciers. These are going to be high up in the mountains, very close to as high as you can get in the mountains, really. And these are these sort of bowl-shaped features over here. Take a look at a picture, it becomes very evident that you have this sort of curved shape mountain here. In this case, it's where the glacier begins, very head of it. We have valley glaciers, as you might imagine. These are found in valleys. So this is going to be flowing between two sort of topographic highs on either side. Typical case is going to be mountain ranges, and in this case, it actually helps carve that valley deeper. As the glacier moves, it rips up rock material and anything really that's underneath it and on the sides and in its way. It helps to make that valley deeper and deeper as it moves. So in this case, these are going to be right here. Right? These are valley glaciers. Again, same sort of block of ice as all these other parts, but when they're in a valley, they are valley glaciers. So you can actually see on this, you have a couple of smaller valley glaciers here and here, which sort of form together to form this big valley glacier here in the middle. Ice caps. So these are going to be at the very top of the mountain, topping the peaks. They usually form these sort of rounded dome-like shapes at the very top of whatever topographic high. Tend to be high elevation and drained by a series of smaller glaciers. So this is going to be, it's a little hard to see the topography on this, but this is actually the highest point on our little diagram here. Picture it maybe gives a little better sense. It's going to be at the very top of the mountain, nothing higher than this. We have this sort of dome-shaped ice cap on top. These fjord glaciers, is a pronunciation. These are valley glaciers, except that they have hit the sea or the ocean. They flow all the way out to where it hits big marine waters. These are a lot of times responsible for the calving, as a term, splitting off into a bunch of small icebergs, which then go out and wreck everybody's ships. You can actually see in this photo here. So here it is a valley glacier until it reaches the sea. Now it's a fjord glacier, and our little little iceberg friend down there. Piedmont glaciers are our last example. So these, I think about where the ankle turns into a foot. You have a place where a really steep valley spills out into a relatively flat area. It's like a pancake. It spreads out in all directions as much as it can, forms this kind of bulbous-shaped, flat, round, expanding thing, like in this example. So we have Valley Glacier here, and then once it hits the flat area, it becomes a Piedmont Glacier. Next section, stick around, we're going to be talking about some of the landforms that result whenever you have glacial erosion and carving of, say, a mountain range. See that.